we're going to work on the practice test for just 3 sections, section 2.6 to 2.8. And I did run off these copies before we decided to split it that way, so if it really bothers you that this says 2.5, switch it to 2.6. And we're also going to cross off some problems on here because we already did these. If you are looking at 8 and 9, you'd say, hey, we did that stuff on the last test. Yep, so cross those off. We don't need the 8 and 9. Already covered them. And I don't think I even copied off this one for you guys, but this is an old notebook, smart book file, so we also did the linear regression. So we have 7 problems to focus on. Lots of time to double check, all that good stuff. Number 1, write an equation that translates the parent function y equals x squared to the left 3 units and down 4 units. So in 2.6 we said these transformations are going to work for all kinds of things. And then in 2.7 and 2.8 we focused on lines and absolute value. Here's the big deal about what they just said. It has to be something with a squared. So squareds means parabolas. So I start thinking, when we did the parabola stuff, I showed you this formula. A, H, and K that has to do with being squared. So that squared is huge. You're not going to get a parabola without that squared. We need that piece. Now we just have to figure out where all the rest of this goes. So it's going to be translated to the left 3 units. Help me out. Where does something like that go in this equation? Exactly. How about a down 4? Where does that go? Did they change anything else? So then the question is, well, what was A already? Because they didn't change it or they would have told us. So what was A when it looked just like this? It was a 1. So, like I said, I don't think I'm going to take off if you put the 1 there. But if we think about it, when we simplify and go over here, we wouldn't write it down. Because 1 times the quantity x plus 3 squared is just going to be x plus 3 squared. So we wouldn't really need it. So only if they talked about vertical stretches and compressions and reflections would we need to worry about what's going on with A. But looks like we're just going to test you on left, right, up, and down. So talk to a chicken wing elbow partner. What am I going to see as the most likely mistake tomorrow? And we're all going to avoid that mistake. Talk to each other. What would the most common mistake be that I'm going to correct tomorrow after school? Where is it? No, this problem, the one we're still doing. Right there. Somebody's going to put x minus 3. Happens all the time. Remember, x is the naughty variable. It always does the opposite of what we tell it to do. So if this says x plus 3, that's what's going to take it to the left. So don't be one of the people that makes that mistake. Think through it and get it in the right spot. Number 2, describe the transformation of the parent function. Now this time we're starting with the absolute value graph. So hopefully when you saw that, you got a V in your noggin, because absolute value graphs are always V's. Wowzers, look at all the numbers they put on that one. The new function is y equals 6, absolute value of x plus 5 plus 7. And be sure to put them in the proper order. So we have taught you to just do this from left to right. Stick with that. So let's see. The first number we see is a 6. What's that 6 doing? Huge vertical stretch, but we can just put vertical stretch factor of 6. So that was the first number we saw. It's the first number we need to explain. If it's a 1, or it's not there, then we don't need to say anything about vertical stretches and compressions because it's not a stretch or a compression. It's exactly the same as it was before. Alrighty, inside the absolute value. What do we say about that one? Okay, but the fancy word. Translate 5 units to the left. Should I put an and? Translate 5 units to the left, and what's the rest of it? Yep. We just explained all 3 numbers in there. Again, watch out for that x. Don't tell us that that's going to go to the right. X is the naughty variable. It's always the opposite. So for 1 and 2, those are the most common mistakes. People mess up that x. So if I were you and I'm worried I'm going to mess that up, I would put a big star here and put x naughty variable. Opposite. So that we remember that piece. Wow, we're already 2/7 of the way done. Let's go to number 3. Find the function g of x that represents the reflection of f of x equals negative 5x plus 8 over the x-axis. Oh, goodness. Okay. Somebody tell me what on earth we're supposed to do. Reflections were 5 days ago, Cedar Home. I'm not sure I remember. Jesse? I got to say no. You're on the right track, though, thinking that way. Jack? Nope, you're overthinking. Well, there isn't a y. Ah, this is why. Now, I saw a couple of people doing this type of thing, kind of thinking through their head here. Okay, it goes from here to here. So the y is going to be made negative. Yeah, remember reflections are about opposites, so we're going to put a negative right there. Are we going to stop? No, that doesn't look right. What would we do? Yep. Tell a chicken wing elbow partner why that would lose 1/4 of a point. Did you catch it? We got to give it a fancy new name. Alrighty, so on the test, if it says we have to reflect over the x-axis, we're going to put a y in there for that fancy function notation and put a negative on it. And then we'll simplify and rename it. If it says reflect over the y-axis, what gets the negative? Just the x. So reflections are about opposites. They're about opposites as well. So far, so good for the first 3. Okay. Oh, graphing. We're good at this. Bless you. Graph the function. Clearly mark at least 3 points on the graph. Identify the vertex and the axis of symmetry. Before we start graphing, because I know some of you are already doing it, talk to your chicken wing elbow partner about the shape of this graph. What do you know about the shape of this graph? So any possibility this is going to show up as a line? So don't graph it as a line. That's the most common mistake that happens with this one. This is a V. So think about that right away. In fact, if you have to, write it down, V-shaped. You know, as soon as you see absolute value. But we also want to write down our little generic formula, y equals a, absolute value of x minus h plus k, so that we don't mess up on the x coordinate. Where's a good place, good something we should look for if we're going to start graphing? Absolutely. You have to be careful with this one. Where's the vertex for this graph? Yes. Well, let's get that on over here. That's definitely not a V yet. So what do we use next so we can start making a V? The slope? Okay, so what's the slope? Three over 1. Is that the slope for both the right and the left? No. Just which one? Ah, so from here we're going to go up 3 and right 1. Still not a V. So what would you do next? Do the opposite. So up 3 and back 1. Now, some of you maybe you're saying, I probably would have used the axis of symmetry. That's a good idea as well, because see how we have a space over there? We have to tell them where that's at. Bless you. And it has to be an equation. You can't just write down a number. You have to say vertical is x equals something. What does x equal? 2. We already had our vertex. Do I need to worry about dashed or solid with this one? This is an equals. Equals, we don't do that stuff. For equals, we just go ahead and make the V. No shading. No. That's all the inequalities. Remember, the latest stuff we did was inequalities. So less than, greater than, less than or equal to, greater than or equal to. Speaking of inequalities, that's the next piece down here. Graphing inequalities. Graph each inequality. Tell somebody sitting around you, a chicken wing elbow partner, what this is going to look like when we get done. Is this a V? No, this is a line. Now, while I was eavesdropping, I heard two different things. Somebody said, you know what, I'm going to do y equals mx plus b. Now, we talked about that. You can do that if you're good at it. You know, you can do the y equals mx plus b. But this one was actually made for the thumb method. That's what this one was made for, because what form is this in? This is standard form. So this is supposed to be a quick and easy, make use of those thumbs, and all will be good. We pretend it says equals, -8. Put the thumb over the x in this position. Well, x up there, I'd cover it up, and it says 2 times something is -8. What's the something? For the next one, the y needs covering up, because that's where the 0 is, so that's gone. 4 times something is -8. What's the something? -2. We already have 2 points. 0, -4, and -2, 0. Then you got to hit your pause button, because I know you really want to draw that solid, but we need to talk about that. Is this one going to be dashed or is it going to be solid? It's dashed. It doesn't have an equals bar. Oh, I might use the slope here to get another point before I try and do this one. 1, 2, 3, 4, and 2 back. 1, 2, 3, 4, and 2 back. That's better. Finished? No? What do we still have to? Yes, we do. We have to figure out which way to shade. So, is 0, 0 an okay point on this one? Yeah, it's not on our line. Let's test 0, 0. 4 times 0 plus 2 times 0, is that less than negative 8? Is 0 less than negative 8? No, that doesn't make any sense. So if 0 doesn't work, well, then it must be shaded over here. But this is a test. And I want to make sure I shaded the right way. So I would want to pick something out here and make sure that it works. And like I've done the last couple of days, people like multiplying things by 5s because multiplying by 5s are easy. So maybe negative 5, 0. Let's check negative 5, 0 and make sure it works. So we'll have 4 times negative 5 plus 2 times 0 is less than negative 8. Well, 4 times negative 5, that's really hard to read. That's better. Is negative 20. Plus 0 is negative 20. So think number line. Is negative 20 less than negative 8? Sure it is. It's to the left of it on the number line. Hey, at least we did the shading right, you know. And maybe, because you'll have lots of time, maybe you decide, you know what, I've got plenty of time to check. I'm going to put this in that y equals mx plus b format, and I'm going to see, does everything work for my line as well. Plenty of time tomorrow. Alrighty, let's switch gears to number 6. Tell a chicken wing elbow partner what that graph's going to look like when we're done. What's the shape? We're back to V's, right? How do we know we're back to V's? Absolute value. V-shaped. Now, we'll put our formula down. Y equals A, absolute value of x minus h plus k. Hey, did we get lucky? Is that already in the right format? Yeah, yesterday's stuff we had to move things around, but this one is already in the right format. Cool. So, what's step 1 to getting our boundary V on there? Vertex, okay. So be careful. Where's the vertex? Good. 1, 1, 2, 3. Then what do we need? Slope of the right side? Okay, what's the slope of the right side? Good, negative 2 over 1. So A, the slope of the right side, we'll use negative 2 over 1. So what does that mean? From that point, I need to go down 2 and write 1. Oh boy, it's hard to make out these lines. Got to hit your pause button. Take a look. I'm hoping somebody says, Cedarholm, you did something wrong. It's not a line. Happens every year. Every year somebody does that. They get going and they say, got all of this, but we were supposed to start at 1, 3. We're not supposed to put anything more up there. I want that axis of symmetry on here because I know a lot of you are using opposite slope, but I also know some of you aren't, and that's okay. Now, it doesn't say we have to tell them the equation for it, but let's do it anyway, just for more practice. What's the equation for that axis of symmetry? Is x equals 1. There it is. So let's get the other side on here. Done? First of all, I didn't make arrows, and we all know that's going to lose us a quarter of a point. What else didn't I do? Didn't make it solid. It's got an equals bar this time. And somebody else said, shading. Yeah, totally forgot about the shading. Don't have any of that done either. So there's plenty to do with each one of these problems. You just have to think about it. So, shading part. Can we test 0, 0? Not this time. See how our V goes right through there? Well, how about 1, 0? Could we test that one? Let's do that. 1, 0 is a nice little number there. 1 and 0. So we will have 0 is greater than or equal to negative 2 times the absolute value of 1 minus 1 plus 3. Bless you. What's 1 minus 1? 0. What's the absolute value of 0? 0. What's negative 2 times 0? 0. So this is going to say 0 is greater than or equal to 3. Well, that's not true. So what does that mean? Jackson. This is where 1, 0 was, and it didn't work. Outside. It's a test, so I would want to double check, make sure that my shading is right. So maybe I'll pick something like 0, 5. It's supposed to be shaded. I'll try 0, 5. So back in the original, that would be 5 is greater than or equal to negative 2 times the absolute value of 0 minus 1 plus 3. What's 0 minus 1? What's the absolute value of negative 1? What's negative 2 times 1? Negative 2 plus 3. My shading's right. 5 is definitely greater than or equal to 1. Cool. Well, that means we only have one problem left. And there it is. That's why today when you asked for this one from the homework, it was a line that we had to do for inequalities. I said, ooh, good problem. Because now we have to write it. So, Elsa, were you the one that said, should we always use y equals mx plus b? I think you were. I'd love to use that. If b is something obvious, that would be a good idea. Is b something obvious up there? What is it? It's negative 2. So we know it's going to be y something, mx plus b. Like so. We'll talk about the something in a little bit. But we also need the slope. So, this is a very nice grid point, and this is a very nice grid point right here. You could either write those two coordinates down and use the formula, or you could count from left to right. You'd have to go down 2 and right 3. So down 2 and right 3, what is that as a slope? Negative 2/3. Alrighty, so we're at this point. We've got the negative 2/3 and the minus 2, and now we just need to know what we should use for an inequality. Are they shading up or are they shading down? So it should be greater than. Do I need to put an equals bar on? How do you know that? It's dashed. It's not solid. And this is a test, so I would definitely test a point. And 0, 0 would be a great one to test because it's supposed to be shaded. So if we put 0, 0 in here, it's going to say 0 is greater than negative 2/3 times 0 minus 2. 0 is greater than negative 2. Of course it is. And because it's only 7 problems, maybe you test another one over here and make sure it doesn't work. I don't know. It's up to you, you know. It doesn't have to do with confidence, but you'll have a lot of time to go through all of that. So, anybody want me to make up a new one of any of these? Feel like you need just one more. All right. Well, then I'm going to get you your review assignment and some graph paper, because, of course, there's lots of graphing here.